So continuing on in the unit on quadratic functions, what we want to cover today is graphing a quadratic function, mainly by using the graphing calculator. Okay. Now, the graphing calculator is obviously very helpful, but if we don't understand what information it provides us and how to use it, then like many tools, it's not of much use. So let's make sure we understand a couple of things. Number one, what is the graph of a quadratic function? As we said yesterday, it's a U-shaped curve called a parabola. Now, we've dealt with the concept of domain and range in many different areas before, with exponential functions, with linear functions. As you recall, the domain are the x-coordinates. Okay. Now, if you are not given, as you might remember in our exponential function, sometimes you were given the domain, sometimes you were not. If you are not given the domain, it will be all real numbers. So it will be all real numbers if not given the domain. Now, the range, as we've said before, those are the y-coordinates. Remember, domain, input, x-coordinates, range, output, y-coordinates. Now, if you're given the domain, then the range are the corresponding y values. So you might remember this again from the exponential functions. If I said to you the domain is from 2 to negative 2, and the corresponding y values went from 5 to negative 5, then the range is y is greater than or equal to from 5 to negative 5. Now, if not given, and there's a lot of words to this, but when you see the examples that we're going to go through, hopefully it'll be somewhat clear to you. Okay? So, if not given the domain, then it's one of two. A, if the parabola opens upward, and remember that's if A is positive, then the range is y is greater than or equal to the y-coordinate of the vertex. If the parabola opens downward, then the range is y is less than or equal to the y-coordinate of the vertex. And again, when we go through some examples, this will be, I think, very apparent to people. Okay? Now, our method to graphing. What's important is that you understand, this orientation is difficult. Okay. What is important to understand is that you just don't want to jump to the calculator while you can. But remember, as I said to you yesterday, a lot of times in the Regents, they ask you to do some of these calculations by hand. So, what do we want to do? In step one, we want to use our formula of x equals negative b over 2a, determine the axis of symmetry. What that's going to do is that's going to tell us the splitting point of the parabola, which means we want 2x values greater than that and 2x values less than that. Okay? Then what we're going to do is we're going to enter the quadratic equation into the y equals section of your calculator, then call up the table of values. Okay? We're going to move the cursor so that our screen has the 5 values noted in step 1 to determine the corresponding values, and then we're going to plot the points. Okay? All right, so let's go through some examples here. And I'm going to orient the board again while we're doing this. So we want to graph the quadratic function y equals x squared. Okay? So as we said, the first thing we want to do is we want to identify or determine our axis of symmetry. Okay? So when we go through and we do y equals negative b over 2a, b is 0, so it's 0 over 2, so the axis of symmetry is x equals 0. So what that means is 0 is going to be the value right in the middle of our table, and we want 2x values above it and 2x values below it. Now, obviously, you could just do this by hand because it's so simple, but just to show you on the calculator, we go y equals, we're putting in x squared, we call up our table of values, and I got to adjust my window, and it starts at 0. All right. And so what you want to do is move the cursor so that 0 is right in the middle. And if you notice the symmetry here, the symmetry is I have 9 and negative 9. I have 4, 4, 1, 1. And the only value that doesn't repeat is the 0, 0. Well, why is that the case? Because that's my axis of symmetry. And my vertex doesn't have a matching point on the other side. So what am I going to do? I'm just going to list out these other coordinates of 4, 1, 0, 1, 4. You notice the symmetry. You plot the points. Now, my domain, and I'm just going to erase this up top just to give me some room to write it. My domain, well, I didn't tell you what to use, so my domain is x is all real numbers. Now, if you look at the graph, the y values bottom out at the vertex. So since this opens upward, y is greater than or equal to 0. Okay? All right, let's do another example. Y is equal to x squared plus 3. I find that my axis of symmetry is x equals 0 still, when there's no value for b, which then means it's 0. I plug this into my calculator to get my 4 corresponding points. Here is my vertex. I'm going to plot these points. My orientation is back to being a little bit off. Okay. Now, what is my domain? X is all real. What is my range? Y is greater than or equal to 3. Now, what happened between this curve and the curve above it? And hopefully you'll see that this one shifted 3 units up, which is a translation, okay? And hopefully you'll notice the y-intercept. What is the y-intercept of any quadratic equation? It's the value of c, since It is the value of y when x is 0. So in other words, when x is 0, that means the x squared and the bx part are both 0, and I'm just left with c. All right? Now I want to do y equals 1/2 x squared. All right? I'm not going to go through all of the work, but you should understand that the vertex is at 0. Again, I'm getting all these values from my calculator. Okay? And I'm going to plot the points. I'm sorry. I'm going to use, I should have made this point here. Since 0, 0 is still my vertex, but I want to count by 2's because if I use odd numbers, I'm going to get decimals. Okay? So, -2, 2, 8, all right. Now, how is this similar? This is similar to absolute value in that the graph widened when multiply by a number less than 1 and greater than 0. Okay? What's my domain? All real numbers. What's my range? Y is greater than or equal to 0. Okay? Now, let's see what happens when these get a little bit more sophisticated. I want to figure out that my axis of symmetry is -4 over 2 times -2, or x equals 1. So that allows me to come up with where I know my table of values are going to be. I know when I look this up on my calculator that it's okay to count by ones. So -4, 2, 4, 2, and -4. Okay. Now, what should you be expecting to be different here? Well, hopefully you're expecting and should know that this should be opening downward because the A is a negative, which we will see in a moment. The domain is all real numbers. And the range, what's now a little bit different, y is less than or equal to, here's my vertex, so I'm using the 4, and you should be able to see that I top out at 4. Okay? Now, last example. In physics, there is a formula that determines how quickly a object descends, okay, from a given height. So we have an acorn drop from a 20-foot branch, right? That's where the 20 is. And the formula is that h, the height, is -16t squared. What is the graph of this quadratic function? Now, what we're going to do here is we put this into our calculator. Now, one of the things, I'm just going to go to my computer to put this in because the orientation is a little. One of the things when you do this, I'm going to go to y equals, clear that out. Now remember, you put the negative sign that's under the 3 in first, -16 x squared plus 20. and I call up my table of values. Now, you're going to see that these numbers get very large very quickly. So one of the things I want to do is maybe not go up by integers of 1, but if you go to your change table here, I can make that go up by half. Okay? So now I go back to my table of values, and I can get a better idea of what happens. All right? Now, one of the things that you're hopefully recognizing is that I can't be outside. Let me just go back to, I can't be outside the first quadrant, all right? Because I can't have negative height or negative time. So when I graph this, if you looked at your table of values, I'm going to use the following 4 values. Because I want to find out about when the acorn will hit the ground. Well, and what I'm going to do is spread this out a little bit. I'm going to use that as 1. That is 2. That's 10. And that's 20. Okay, so I'm going to use that as my intervals. So at 0 seconds, I'm at 20 feet high. At half a second, I'm at 16 feet. Okay. And let me just, actually, I'm going to move this up 2 more. So 2, 4, 6, 8, 10. Yeah. 2, 4, 6, 8, 10. 20. Okay. So now at half a second, I'm at 16. At 1 second, I'm at 4. And at some point, a little between 1 and 1.5 seconds, okay? So here's 1, here's 1.5. Somewhere around here, I'm going to, oops, screwy there. I'm going to hit the ground, okay? So one way you could do this is you can see by hand. I want to find out when my height is at 0. And later on in this unit, I'm going to show you how you can figure out what this number is on the calculator. I can solve this. Okay. T squared is 20 over 16, so that t, I'm going to take the square root of each of these, so that t is about 1.1, which is what I was expecting here. Okay. So what we covered today is how to use the graphing calculator to help us graph quadratic functions.